Hello and welcome students. This is lecture on circles. We have already completed exercise 17A, and before we begin with exercise 17B, we will have to do certain important results. So this is the first important result. See, some of the important results we will do, and then we will begin with the problem solving in exercise 17B. See, the first one is equal chords subtend equal angles at the center of the circle. So equal chords, you can check here when you have equal chords in a circle, then such equal chords will subtend equal angles at the center of the circle. Okay, you understand the meaning of subtend? Subtend is what? To make. So see that in this circle, there are two chords which are equal. AB and CD, these are two equal chords. AB is equal to CD. Now, what angle is AP subtending at the center? You can check. AB join from A and B, join the extremes of the chords, that is, join the point A with O and join the point B with O. Look at the angle which you get at the center. This angle AOB is angle subtended by chord AB at the center. And here this angle COD is the angle subtended by chord CD at the center. But you know what we are given? We are given that AB is equal to CD. Chord AB is equal to chord CD in length. Got that? And if this is the case, remember that angle AOB, you don't have to prove it, just remember the result. Angle AOB, which is subtended by chord AB, will be equal to angle COD, which is subtended by chord CD. This you have to remember. Okay. Now the converse. Now the converse of above result. The converse of above result is also true. Converse of above result is also true. What does it mean? See, the converse of above result is also true. I'll tell you what does it mean. It means this time we are given two angles subtended by two chords at the center. Okay, and we are given that these angles are equal. So here I will write the converse. See, in a circle, if two angles subtended by two chords are equal, then the two chords are also equal. Try to understand. This time, what you are saying the angle subtended by two chords at the center of circle are equal. This time what you are saying, students? You are saying the two angles subtended by two chords at the center of a circle are equal. This time you are saying that two angles are equal. And if the two angles are equal, subtended by two chords, if these two angles are equal, then the two chords will also be equal, which is converse of the first statement. In the first statement, what you had said, you remember? You said the chords are equal. First you said the chords are equal, and then you said because the chords are equal, the angle subtended by them at the center will be equal. Here, what you are saying? Here you are saying that there are two angles subtended by two chords, and the angles happen to be equal, so the chords will be equal. I hope you followed it. You can copy this first. Now here in the second result, students, I have drawn four figures. This is figure 1. Okay, this is figure A. This is figure B. Figure C and D. This is figure A. Now, what I want to actually show it to you is, in this figure, in this figure A, you have a triangle inscribed in a circle. Now, what is important that all the three sides of this triangle are equal. That is, it is an equilateral triangle which I have inscribed in a circle, right? And then in the second figure, I have a quadrilateral which is inscribed in a circle. But again, the four sides of the quadrilateral are equal. That is, I have inscribed a square inside a circle. Square inscribed a circle. Then I have in figure C a pentagon. You can check there are 5 sides. Okay. I have inscribed a pentagon inside the circle, and once again, all the 5 sides, a pentagon has 5 sides. All the 5 sides of the pentagon are equal. Now here you don't have to go by construction. Understand that these 5 sides may not look equal, but then just consider them to be equal. Think they all are equal. And here I have in figure D hexagon, where we have 6 sides and all the 6 sides are equal to each other. Now remember, students, such polygons where all the sides are equal, they are known as a regular polygon. So this is a regular pentagon. This is a square. Okay, it has a specific name. This is a regular pentagon and this is a regular hexagon inscribed in a circle. Now all these circles have their center O. They have center O. So here I write the triangle as ABCD. I'm sorry, triangle as ABC. Here I write the square as ABCD. I write the pentagon as ABCDE and hexagon ABCDEF. Now, as in this, the triangle is an equilateral triangle, so AB equals to BC equals to AC. So these 3 chords are equal. And if these 3 chords are equal, you understand that angle subtended by these 3 chords will be equal. The angle subtended by these 3 chords at the center of the circle will be equal. So if this center is O, as I said, in this case, what will happen? This central angle will be divided into 3 equal parts. Understand that these 3 angles are equal because they are subtended by equal chords. So I can say that the central angle is divided into 3 equal parts. Now you know that angle around the center of a circle is 360 degree. So 360 degree divided by 3, that is equal to 120 degree. So what is the angle subtended at the center of a circle by the sides of an equilateral triangle? It is 120 degree each. Now let's do the same thing in case of square. So see, side AB subtends this angle at the center. BC subtends angle BOC at the center of the circle, and side CD subtends angle COD, AD subtends angle AOD at the center of the circle. Now, since these chords AB, BC, CD, AD, they are all equal, what will happen? The angle subtended by them at the center will also be equal. That is this angle, this angle, this angle, and this angle. These four angles are equal. They are all equal. Now you understand the central angle, that is the angle at the center of a circle, is 360 degrees. So each angle will be 360 degree divided by 4, that is 90 degree. Each angle here is 90 degree. Why? Because the central angle is divided into 4 equal parts. So 360 upon 4 gives you 90. So angle subtended by, what I can say in the case of figure 2, I can say that angle subtended by the sides of a square inscribed in a circle is 90 degree at the center. Here what I can say that angle subtended by the sides of a square inscribed in a circle at the center is 90 degree each. Now here you have a pentagon, and again this is a regular pentagon. So if it is a regular pentagon, what will happen? All the 5 sides are equal, and hence these 5 angles subtended by these 5 equal sides at the center will be equal. So you will have that 360 degree divided by 5, that is equal to 72 degree. The angle subtended at the center by each side is 72 degree. And here, look at this. You have a regular hexagon this time. So there are 6 equal sides, and the angle subtended by these 6 equal sides at the center will be 6 angles, and those all angles will be equal, remember. So the 6 angles are equal. So what will happen? The central angle that you will have is 360 degree, and it is divided into 6 equal parts. So each part is 360 upon 6, that is equal to 60 degrees. So what you can say? You can say that angle subtended by a regular hexagon, the angle subtended by the sides of a regular hexagon inscribed in a circle at the center of the circle is 60 degree each. You can plot, you can draw it and write it. Yeah, look at the third result here. This is also very interesting and very important result. In a circle, you have 2 chords, say AB and CD, and the length of chord AB is say 6 centimeters, and chord CD is equal to 12 centimeters. Now what do you understand? You understand that AB upon CD is 6 upon 12, that is 1:2. So what you can say is AB is to CD is 1:2. The ratio of lengths of the chord is 1:2. Okay, that is chord CD is 2 times chord AB. You can check. Look at the length of the chord CD. Chord CD is 2 times length of chord AB. Chord CD is 2 times the length of chord of AB, right? Remember, if chord CD is a double chord AB, remember that angle which it subtends at the center of the circle will also be double. What what I want to say is, suppose this angle happens to be 32 degrees at the center. If this angle is 32 degrees, then this angle will be 64 degrees. Yes. If CD is double AB, the chord CD is two times of chord AB, then angle subtended by chord CD at the center will also be two times of angle subtended by chord AB at the center. So if AB is to CD is 1 is to 2, remember, if AB is to CD is 1 is to 2, then the angle subtended, that is COD, angle COD, I'm sorry, AB is to CD is 1 is to 2. So angle subtended by AB, that is angle AOB is to angle COD will also be 1 is to 2. This angle divided by this angle will also be 1 upon 2. So by this, what more can you say? You can say that suppose I have, what I can say is, if chord AB is to chord CD is equal to 4 is to 7, then angle subtended by chord AB, that is AOB at the center, is to angle subtended by chord CD at the center, that is angle COD will also be 4 is to 7. I hope you followed it. Please copy this also. Okay, so here I have three chords which I have drawn in a circle, and these three chords, remember that they are equal chords. So I will write here chord AB is equal to length of chord CD, which is equal to length of chord EF. So these three chords are equal in length. Now I go for the angle subtended by these three chords at any point on the circle. So see here. Here I have this angle. I can have it here. I can have it here, no problem. Okay. I could have had this angle anywhere. See, for example, I had it here. So if this chord is subtending an angle here, right? At point, this point is say G. So angle AGB. This angle is subtended by arc AB at one point on the circle. Okay, at some point on the circle. But what is important is this angle could have been anywhere, not necessarily where. I could have taken it even here, that is okay. No worries. See, even that is okay. Remember, the angle here or the angle which I had taken here, they are same angles. They are equal angles. You know why they are equal angles? Because they are angle in the same segment. You can check chord AB divides the circle into two segments. See, this is one segment. This is one segment. Okay. And here you have the other segment. So with the help of the chord AB, you can have the angle anywhere made on the circle. You can have the angle anywhere made on the circle. So I had it here, I had it here. You can have, you can have this angle AB. You can have the angle made by the subtended by the chord AB any elsewhere, and even this angle, will be equal. This angle will also be. So that is all okay. That was not my intention. I wanted to do something different, but then Okay, so what I'm saying here is, so I have here angle subtended by AB, chord AB here on the circle somewhere. And what is that angle? This is the angle. This is the angle subtended by chord AB. Then I have angle subtended by chord CD at some point on the circle, and say here it is. Here. What is that angle? This is the angle. And I have angle subtended by chord EF at some point on the circle. Now, what is important here, students, try to understand that since these chords are equal, so the angle subtended by these chords at any point on the circle will also be equal. That is important. Chord AB equals to chord CD equals to chord EF. So what is the angle subtended by chord AB? Check. See, this is the angle subtended by chord AB. This is the angle. What is the angle subtended by chord CD? It is this. And what is the angle subtended by chord EF? It is this. So remember, students, these three angles will also be equal. So what I write? I write here equal chords. I write here equal chords of a circle subtend equal angles at a point on the circumference of the circle. And the circumference of. So here you said that chord AB equals to chord CD equals to chord EF. Chord AB equals to chord CD equals to chord EF. So you can say therefore angle AGB is equal to angle CHD is equal to angle EIG. Okay, this is done. Now there is something more to it. And see, students, earlier to this we have done, or if you remember, earlier to this we have done. Okay, fine. One more thing that we can add here is the converse of this will also be true. The converse of the above statement, the converse of above statement will also be true. The converse of above statement will also be true. What does that mean? Suppose I'm given that angles are equal. Suppose I'm given this angle which is subtended by chord AB at some point on the circumference is equal to this angle which is subtended by some other chord at some point on the circumference, and these two angles are equal. So if these two angles are equal, I can say that the two chords will also be equal. So this converse is also true. Remember that the converse is also true. So that's it. Enough for today. We will use these problems to solve. We will use these results to solve some more problem in the next lecture. Thank you.